This is lesson 403, Tangents and Secants. The objectives of this lesson is to define and identify tangents and secants, and to use the tangent theorem and its converse. Here are the key terms that we're going to be going over in the lesson: point of tangency, secant, and tangent. A circle and a line that lie in the same plane can intersect at 0, 1, or 2 points. One point of intersection is called a tangent. The line that you see here, the red line, is tangent to circle A, and the point at which a tangent and a circle intersect is called the point of tangency, right here. And point D is the point of tangency in this example. When a circle and a line intersect in 2 points, the line is called a secant. Secant CD intersects circle A at points C and D. Notice that the secant contains a chord from this point to this point. From C to D is a chord. A chord of circle A. We have the tangent theorem that says a line that is tangent to a circle is perpendicular to a radius of the circle at the point of tangency. And you can see how that's happening right here. And it always works that way. Anytime you see a radius that intersects a tangent at the point of tangency, you know that it's forming right angles. And the converse of the tangent theorem is also true. A line that is perpendicular to a radius of a circle at its end point on the circle will be the tangent. Okay, so if you see a line that's intersecting the radius at the end point of the radius on a circle, you know you have a tangent line. If line AC is tangent to circle B, then what is the measure of angle ACB? Okay, I paused the recording. I'm not sure where I stopped at. So here we are at this example. It says if line AC is tangent to circle B, then what is the measure of angle ACB? Well, if you look at this, let me get my pen. We know that this angle right here is 65 degrees. We know that the angle BAC is 90 degrees. Alright, so we could take 180, and we're looking for this one right over here. We've got 180 minus 65 minus 90, or you could even say 180 minus 90 equals 90, and then subtract 65 from that, and you're going to get, I can write it out here, 25. So the measure of this angle ACB is going to be 25 degrees. Let me write that out officially. Measure ACB equals 25 degrees. Okay, it says if line LK is tangent to circle, is line LK tangent to circle J, why or why not? Well, it says that, we got the theorem that says anytime we see a line intersecting a radius at its endpoint on the circle right here, that it's going to be perpendicular, but that's not really going to be our reason. Let's look here. You've got to remember from the when you learned about Pythagorean theorem, you were also supposed to learn about Pythagorean triples. Okay, and so if you have your legs that are 3 squared and 4 squared equals 5 squared, which is the hypotenuse. Remember your Pythagorean theorem? Okay, so you're going to say 9 plus 16 And does that equal 25? 9 plus 16 is 25. So that proves that that is a right angle there. And we can say, yes, line LK is tangent to circle J because the triangle is a 3, 4, 5, and that meets the converse of the tangent. Whew, that's a lot of writing. Theorem. Okay, radius AB is an altitude to equilateral triangle DAC. Find the measure of angle ADB. So remember, when they tell you it's an altitude, that means it's the height. So this AB is going to be the height of the equilateral. And you remember, equilateral means that DAC, all three sides have the same measure. Now we're looking to see the measure of angle DAB. Wait, ADB. So over here. I looked in the wrong spot. There we go. I got rid of that line. ADB. Alright, well, one thing we know is that if it's an equilateral triangle, we know that the measure of angle DAC, which is this right here, equals 60 degrees. Well, since AB is the height or the altitude of the equilateral, that means that we can divide that by 2 and it's going to equal 30 degrees. So this angle is 30 degrees and this angle is 30 degrees. We also know that whenever you have the I'll get it right in a minute. Whenever you have the altitude of an equilateral, that tells us that it's perpendicular to the base of the triangle. So it's all easy cheesy here, because you have 80 minus 90 equals 90, and then you've got to subtract that 30, and it equals 60 degrees. Now then, if you hadn't have gone that way, you could have just said, hey, all the angles of an equilateral are 60. So that means that angle ADB is 60, angle ACB is 60, and of course angle DAC was 60. But any way you do it, it's going to come out right, no matter what your train of thought is. Always remember, there's probably more than one way to solve a math problem. Radius AB is an altitude to equilateral triangle DAC. We just learned that. If line BC is line BC a tangent to circle A, why or why not? And this one says is exactly what I told you in the last one. Matter of fact, I've already answered B. Let's say since AB is an altitude of the equilateral, I will. Equilateral triangle DAC, ABD is a right angle. So that tells us that this right here is a right angle. Well, either one of them. Make sure I mark the right ones. And remember, anytime you have a line right here, a line that is perpendicular at the end point of the radius, that means that line is tangent. So we're going to say yes, it is tangent by the converse of the tangent theorem. So what we learned today is a tangent to a circle is a line that lies in the plane of the circle and that intersects the circle at exactly one point, the point of tangency. Let me change this to my arrow. There we go. A secant to a circle is a line that lies in the plane of the circle and that intersects the circle in 2 points. Every secant contains a chord. And the tangent theorem states that a line tangent to a circle is perpendicular to a radius of the circle at the point of tangency. And the converse of the tangent theorem states that a line perpendicular to a radius of a circle at its endpoint on the circle is tangent to the circle. Blah, 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 blah. That's the way I feel when I read that. Sound like the Peanuts teacher. Wah, 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 wah. Okay, you should, after you watch this video, view the LMS lesson 403, Tangents to Circles 1, and complete the student guide, because remember, you can use your notes and your geometry textbook whenever you're taking the test. Read the lesson and the reference guide to add extra notes if needed. And then complete the following problems in the problem set. It's just 1 through 9 odd, so there's not that many. After you get finished completing those, if you have any questions, please contact me or attend TOGA before you complete the quiz. And as always, make sure that you make note of any general questions you may have when you attend CC or CCO on Thursday. And again and again and again, please supply me with your course number, which is 202B, and your section number, which should be 1 through 1, 2, 3, or 4, with all communication to me so I can help you faster. That's going to be it for lesson 403. Thanks for listening.